We use the Rydberg formula to find the wavelength of light emitted when an electron in hydrogen drops from n equals 3 to n equals 2. Here's the problem. Using the Rydberg formula, analyze the hydrogen emission spectrum for the transition from n equals 3 to n equals 2, a Balmer series line. The Rydberg constant is 1.097 times 10 to the 7 per meter. Determine the wavelength of the emitted light and identify its color. First, write the Rydberg formula with the final n equals 2 and initial n equals 3. 1 over lambda equals r times 1 over n underscore f squared minus 1 over n underscore I squared, which is 1.097 times 10 to the 7 times 1 over 2 squared minus 1 over 3 squared. Now evaluate the bracket. 1/4 minus 1/9. 1/4 is 0.25. 1/9 is approximately 0.1111. Their difference is 0.1389. Multiply by r to find 1 over lambda. 1 over lambda equals 1.097 times 10 to the 7 times 0.1389, which equals 1.524 times 10 to the 6 per meter. Take the reciprocal to find lambda. Lambda equals 1 over 1.524 times 10 to the 6, which equals 6.56 times 10 to the minus 7 meters, or 656 nanometers. The wavelength 656 nanometers corresponds to red light, known as the H-alpha line. Remember, the Rydberg formula gives the wavelength of light emitted during electron transitions in hydrogen, and the Balmer series corresponds to transitions ending at n equals 2, producing visible light.